Okay, graphing 101. What do you actually need to know about graphs? What we're going to do is we're going to go into point by point by point. Some of you, it's going to be very basic, that's fine. We just want to make sure everybody's up on what needs to be done for every class. Right? So we want to make sure we're all on the same page. Because this is the first graph you get involved with. And we're talking about the budget line graph. And I always get a lot of questions about this. So first off, we're going to go into exactly what graphing is all about. Second off, when we have graphs like this in the textbook, we will go over each and every graph to go ahead and make sure everyone understands it. And we do that in every chapter we go through. So don't worry about if you look at this and you go, oh my God! If it confuses you in the textbook, trust me, it's confused people before. I've been teaching economics now for 18 years, and I know what confuses people. So we're going to go through them all. So don't worry about it if you get in the textbook and you go, I should have had a V8 or something like that, okay? We will go over them all so that you will understand them. All right, so first I want you to do is I want you to get this Graphing 101 note sheet up here, okay? All right, it looks kind of like this. I got to make these things a little bit smaller, I guess. But we're going to start out with looking at the line going up and down. They call it the vertical or the y-axis. Now, why do I do that? Because in some versions of the book, in the same paragraph, they talk about vertical axis and they talk about y-axis. Now, if it's in the same paragraph and they're using different words, a rational person would think that they're talking about different things and you'd get totally confused. But actually, they're not. They're both talking about the line going up and down. Okay? Now, the one on the bottom, whoops, horizontal or the x-axis. Now, normally, we see one side of the graph is going to have to do with money, all right? In this case, our example we're going to go through has to do with ticket prices. But notice in parentheses, it's also going to say something. This one says in dollars, meaning that all the numbers on this side are going to be in dollars. Now, sometimes that'll say in thousands of dollars, millions of dollars, billions of dollars, or even trillions of dollars. The parenthesis is going to tell you what those numbers represent. Now, on the bottom, you normally have to do with quantity. In this case, we're going to be taking a look at attendance. And as this one says, in thousands. So every one of these numbers represents, if this was a 1, it would represent 1,000 people coming to the game. Which, speaking about, that's what we're going to do. We're going to take a look. The Orlando Magic is thinking of moving to Jacksonville. And at this point I say, why would a professional franchise move from one city to another? And here's where you go, make more profit? And I'd say, yes, that's exactly correct. Make more profit. That's why they would move. Right? Now, what we would do before we move, though, because we're talking about a multi-million-dollar franchise here. So we don't want to move it just on a whim. We want to see if Jacksonville actually has the fan base that's going to make us that more profit. So we're going to go to Jacksonville and we're going to ask everybody. Ask everybody. There's over 1 million people that live in the Jacksonville area. Are we going to ask each and every person in Jacksonville about the basketball team? At this point, you should be going, him. Well, then I'd come and say, how much do you think it would cost to ask each and every person in Jacksonville? And some people with the bright lights going on say, ooh, that'd be a lot of money. That's why we don't ask each and every one. What we do is we do a random sample. Because 1 million is way too much to look at. Now, this would take us into statistics. This is about as far as we're going to go into statistics in this class. There are actually 2 types of statistics, right? One is what they call for attributes. And this just means is something there or is something not there? Okay? Does it have the screw in it or does it not have the screw in it? This is what they call this one. This one is for variables. It measures how much of something, like how many people or not how many people, okay? And you notice you can get them from the American National Standard. They even have a number here that you can take a look at it. This is the 2018 revision of it, so they update it from time to time. But that's where you get all the stuff that can go ahead and lead you to how many samples I need to get and all that stuff. Because when you break it down, this is what you're looking for. First off, here's definitions when we start talking about something, okay? Life-threatening or may result in death, including of a company. May result in temporary or permanent injury requiring medical intervention or financial intervention for a company. May result in a minor injury, discomfort, or inconvenience. In other words, it's a bump in the road. Okay? So, if we take these three definitions, this definition would be a very high-risk choice because your company could fold. This would be a medium-risk choice. This would be a low-risk choice. So what we're looking at is, all right, I'm looking to move my team, so I'm looking for a high risk. Now, I want to have 95% confidence that 99% of the time my choice is going to be reliable. Okay? So 95% confidence. Now this can change. Right? You can make it higher if you want. You just have to have a higher sample size. Reliability. Notice 99, 95, 90%. Bump in the road. Serious injury. Death of the firm. How many samples? 299, 59, 29. And go, well, wait a minute, that doesn't seem very high. Well, remember all those presidential surveys that were, or samples that were taken? They'd get, you know, like 499, 599, 699. They didn't get very high. And that was for 150 million voters. Okay? They don't have to be high if they are statistically random. Okay? That's the key. Not only that, it's that the surveys weren't worded to slant it in some way where it's pushing people to a certain choice. Right? It has to be neutral, it has to be random, and statistically accurate, which is where the table comes in. So that's all you're going to get for stats. You want to know more? Take a stats class. Okay, so here's what would happen. Let's say our statistical sample is going to be of 100 people. Right? That's our random sample. So we get these 100 people, we put them in a room, and we go, hey, the Orlando Magic's coming to town. If they charge ticket prices at $25 a ticket, how many of you would come? 0 hands go up. Ooh, 0 hands, that's not good. $25, nobody's going to show up. Yeah, I know sports tickets cost a lot more than that, but the numbers are smaller, so the math is smaller. So just go with the example. Right now, 20 people, we say, okay, well, what if we reduced it to $20? 20 hands go up. You go, ooh, ah, okay. Now, we're going to see what happens, what those 20 hands represent. 15 hands go up, or excuse me, we say go down to $15. 20 more hands, so now we have 40 hands going up. And then at $10, we got 60 hands, $5, we got 80. $0, if it's free, everybody's showing up. Okay? So, one thing you got to remember, this sampling, depending on how you word the sample, and if it's statistical and random, it's garbage in, garbage out. You give it bad stuff, you slant the questions, it's not random, it's not statistically accurate, you're going to get garbage out. Example, Hillary was supposed to win in a landslide in 2016. Instead, Trump won by a landslide in 2016. Garbage in, garbage out. So here is for the whole population, that 1 million folks in Jacksonville. Remember those first 20 hands that went up? They represented 4,000 people showing up at the stadium. When 20 more hands went up, 8,000. 20 more, 12, 20 more, 16, and when all of the hands went up, that represented 20,000 people would show up to see the basketball game. So the amount of hands represents the amount of people. So that's how all of these tables in the textbook get put together. And this is probably the last time I'm going to explain how they get put together. I just want to go ahead and make sure you understand that as we go through this. Now what we do is plot them. Plot the dots. Well, that means first time we take a look at ticket prices. There they are. We go from 0 to 25. And attendance, we go from 0 to 20,000. All right, now we're talking thousands. The reason they do that is, can you imagine 4 with all of the zeros, and 8 with all of the zeros, and 12, and 16, and 20? And that's just 1,000. What if it was in trillions? Okay? 12 zeros going through there for each and every one. So it makes it easier to read. Okay? So pay special attention to what's in the parentheses so you know what these numbers are representing. Now, for all of you math geniuses, you're going to go, okay, well, we know that when we graph, there's 4 quadrants. One here, one here, one here, one here. We're only concerned with this one. Right? So don't worry about any of the other ones. Just drop it from your imagination for a while. So, we've got our graph. Now we plot our dots. This is where I want you to get the Graphing 101 worksheet, because we're going to go through not just graphing, but some questions. Okay? Now, we talk about graphing. The easiest way to do it is you take one part, let's say ticket price, you put it, all right, there's 25, you run the line straight across the graph. Then you take attendance. Notice it's at 0, so you run the line. In this case, up the graph. Where they cross, that's where you put your first dot. If you have any problems graphing, just draw it, and where they cross, you put the dot. Such as, for 20 bucks and 4,000, there's our dot. And so forth, and so forth, and so forth, and so forth. Right? Now that we have the dots, it's simple. Whoops. We go ahead and connect the dots. Now this is what 3rd graders are doing in Georgia. Okay? They can do this. The question is now, how do we analyze this? Okay? Remember, we make decisions. We have to make choices, so we're looking at getting some kind of information to help us make these decisions. That's where this comes into play. Graphs provide one set of information. Remember, don't let graphs make all of the decisions. Okay? They're there just to provide you with one part of the puzzle. It's up to you to make the choice depending on everything you feel comfortable, all the information you can gather together. So, here's our graph. We did the research on this, okay? Research, statistically random sampling. 100 people out of 1 million, and that's where we got our information from, and we're going to make decisions based off of that random sample. But here's something else. When we drew this line, we're now assuming that every point in between these is correct. So if I wanted to look at $13.87 and how many people would show up, I'd take that number, come over, drop down, and I'd say 8,972 people would show up. Now you look at that and you go, well, you can't possibly figure that out from this graph down to the specific number. There is a math formula that can do that. No, we are not going to go over the math formula. You want to look at and learn how the math formula works? It's in Appendix 1 of the first chapter. Right? Ask your math teacher. Ask your stats teacher. But you can bring it down from the exact penny to the exact number using that formula. All right. So, Oh, that brings me some other point. Remember, in macroeconomics, we're not accountants. We don't go to the penny. We go to, are we in the ballpark? So I want you to remember something. Hand grenades, horseshoes, and nuclear weapons. You just have to be in the ballpark to win. Same concept with macroeconomics, in the ballpark. We can lose $5 billion and we say, who cares? Why? Because we're talking about 26 trillion that we're currently in debt over and increasing. We'll get more on that one later. All right, so now I want you to go back to that previous graph sheet because we're going to add some more definitions here. All right, we've got this curve. That's what we put on the other one, so you can go ahead and draw it in on this one. This is called a linear curve. Why linear? It's a straight line. And it's an inverse curve. Inverse meaning as one number goes down, the other number goes up. And think about it for a minute. If the price goes up, are we buying more or less? Most of you at this point should be saying we're buying less. Price goes down, we're going to buy more. So if they go in the opposite directions, we call that an inverse curve. And there's the opposite directions there. Okay? So that's what this line would actually be called, a linear inverse curve. You will see that in the reading. That's why you need to know what it actually stands for. Because they may not have the graph right there. It might be on the other page. So as you read this, know that if they're talking linear and inverse, they're talking about one that looks like that. Now in the upper top, if you have a curve that goes like this, we call it nonlinear. Why? Because it's not straight. Okay? Why do they call it these? These are just the definitions that you work with in economics. Two things make economics hard for people to understand. The first one is graphing. That's why we're going over Graphing 101. The second is definitions. That's why we're also going over those not only here, but as we go through the rest of the course. Remember opportunity cost. Remember cost-benefit analysis. Right? So, those are the two things that give people the most trouble, graphing and definitions. So it's a nonlinear curve. It's also what we call a direct curve because they go in the same direction. And let's take a look at this example, rainfall and sales of umbrellas. If it rains more, we would expect the sales of umbrellas to, yes, go up. If it starts raining less, the sales will go down. So they're going the same direction. Not the same amount, but the same direction. Okay? So, straight and opposite, linear and inverse, direct and the same direction, and not nonlinear direct curve. Those are the definitions. So as you're going through and reading this stuff in the chapters, this is some of the stuff that you're going to need to do. Now, here's where we get to our math folks again. Independent variables. This is the source or the cause, or this is the variable that we change. On our graphs, let's take a look. What if I change my ticket price? How is that going to affect my dependent variable or the attendance? Okay? That's the effect or the outcome. So I'm going to change this variable, and I'm going to see what happens to this variable. I go from here to here. Well, let me see. I got that. Ooh, I went that way. Not good. Maybe. We'll get to that one a little bit later. So this is what your sheet should look like right now. Now, why am I putting this sheet here? When I said in the previous video, oh, we're not going to do that because this explains graphing. So I want to make sure you understand this. So this is the completion of the first sheet. Now, let's go back to that sheet where you actually started filling out the graph. Why do we graph things? To help us make decisions. And that's where we're going to go with this one. Answer the what if. We're looking at making max profit. So I may need to change ticket prices to see how that works. So what if I change it from this to this? What's going to happen? All right, so let's go back and we're going to ask some what ifs. Remember, we got the 6 data points. We connected the dots. We're assuming that everything is good. And some of you should be going, well, wait a minute. Assuming, that's not a good thing. Well, in macroeconomics, we do make a lot of assumptions. Remember, we're not accountants. We're talking about economics. We're talking about being in the ballpark. Horseshoes, hand grenades, nuclear weapons. Close enough to get the job done. That's what we're looking at here, okay? And marketeers and IT folks that put these graphs together, if they don't put them together with the right stuff, in other words, the right samples, the right wordings, the right statistical analysis, they lose their job. Because we're making decisions based off bad information. So they're only as good as the last graph they put together for us. All right, so what is attendance for $12.50 a ticket? All right, here's the question that's actually on that sheet. So I'll give you a second to go ahead and think about this. All right, now some of you should have come up and went, well, I could have found $12.50 here and then gone straight down and figured out that that was 10,000 people. Or you could have said, well, wait a minute, it's a straight line. $12.50 is halfway between 10 and 15. 10 is halfway between 12 and 8. Yes, you could do that. On this particular one, on this particular example, I would not go ahead and do that for the rest of the textbook. This is the way you want to do it. Go straight across and straight down, or straight up and straight over. And remember, in the ballpark. That's all you have to be. So yeah, we got 10,000 people there. Now, what is attendance for $17.50 a ticket? Now, some of you that might not have exactly gotten the last one might still be scratching your head. Those that almost got the last one or did go and get the last one are going to go ahead and say, well, wait a minute, that's halfway between 15 and 20. So I can figure that out that way again. And remember, I said don't do that. What you wanted to do is, yes, you wanted to go halfway between 15 and 20, come over and come down, which would be halfway between 4 and 8, which would mean we'd have 6,000 people showing up. All right, again, use the graph, not the table. Okay, what is the revenue for $10 a ticket? Now, right now there's confusion reigning in the ranks out there. Because, well, wait a minute, nothing tells me revenue. Well, here's where you have to start thinking about this a little bit. Here's where we go from 3rd grade to college. Okay? All right. We know what the ticket price is, right? We're saying 10 bucks a ticket. So, boom, at 10 bucks a ticket, how many people are showing up? So, can we find that attendance? Yeah. So let's look. 10 bucks a ticket, 12,000 people. So 12,000 people are buying a ticket. How much is each and every one of those tickets worth? 10 bucks. So 12,000 times 10, $120,000. So the revenue for a $10 ticket is $120,000. Now, I want you to find out what revenue is for a $15 ticket. And I'm going to go ahead and let you work this out for a minute, and let's see what happens. Now, here's why you want to go ahead and take notes, because it's the same system that we just did up here. All we're doing is changing the ticket price. So at 15 bucks a ticket, we first have to find out how many people are there. 15 bucks a ticket, we're going to have 8,000. 8,000 people want to buy a $15 ticket. 8,000 times 15, 120,000. Yay! But now we have a choice. What are you going to charge? $10 or $15 a ticket? Because the revenue is the same. Now at this point in the class, a lot of people are going, well, maybe this, maybe that, because of this, because of that, or whatever. The answer is, it depends. And let's take a look at why. Now most people would have come up and said, yep, we want to charge $10 a ticket because we're going to have more people in the stadium. And if you're a vendor, you definitely want more people in the stadium because you make more money. And if you're the team owner, you get a percentage of what the vendors go ahead and sell. So yeah, at this one, we'd want the 10 bucks a ticket. More people, more sales, more profit all around. However, what if you're the cleanup crew? All right? Now, you're the owner. Remember, you got to pay that cleanup crew. Now, we've all seen what stadiums look like after the game is over and everybody leaves. Do you want 10,000 people there? Or do you, let me see, oops, excuse me. Do you want 8,000 people there, or do you want 12,000 people there? At this point, we're going, no, I want less people, so I want the $15 ticket. Less people, less cleanup, less cost, which means I get to keep more profit, okay? So, here's what we're looking at. Which one are we going to do? The $10 vendor or the $15 cleaning company? Because remember the profit formula. The basketball team is going to make more profit if they have more people, but the cleaning company is going to make more profit if there's more people. So the basketball team is also paying the cleaning company. So they're going to lower the cost if they have less people. So this is the revenue side, this is the cost side of the basketball team's profit formula. And then let's throw something else in here. What happens if you only have parking for 11,000? Well, if you went ahead and we went ahead and did the $10 ticket, 11,000 people are really happy, but what about that other 1,000? You now have 1,000 people trying to find a parking spot so they can get there to watch the game. Unhappy people, because if they do find one, they're late to the game, and then it's a long way back to the car once the game's over. Or some people just give up. And upset customers tell bad news 7 times more than good customers that had a good time. So that's an awful lot of bad items on the internet. So again, it depends. Remember, our graph only gives us information for certain things. In this case, ticket price and people. Now we've got people looking at vendors, we've got people looking at cleaning company, we've got people looking at parking places. This adds into our formula. So that's where we start taking a look at this graph by itself isn't going to give us the complete answer. We need more information to get the optimum ticket price for the optimum amount of people in the stands. All right, this is what this sheet should look like. And if you need to fill this out, feel free to put it on pause. You now know 95% of everything you need to do in the textbook on graphing. We'll go ahead and get the other 5% individually on each graph we go over. So as of now, that's it for this topic. We're going to head into the next topic here shortly.